Hello and welcome. This is going to be our lecture video for October 2nd. Go ahead and get out your notes. We're going to do some spot the mistake type problems to get started here. So get out your notes so that we can solve these correctly. What was the mistake made in problem number 1? Here I'll put in a question for you to tell me what you think the mistake is. Okay, the mistake is that we cannot add 13 to both sides because adding 13 doesn't undo the operation here. There's hidden multiplication in between the negative 13 and the n. So how we get rid of that is with division. What we should do is divide both sides by negative 13. That undoes the multiplication, and now we get 9 equals n, or I'd like you to switch that around and make it n equals 9. N equals 9. Put a box around it. Okay, looking at this next one. They subtracted 20, but did they do it correctly? Here, we'll put in another question. So no, they didn't do it correctly. We needed to subtract 20 from both sides. So what would have been the right thing to do is if we're going to subtract 20 over here, we have to also subtract 20 over here, and then we get 14 equals r. Switch that around, r equals 14. All right, problem number 3. Here, what do you think the mistake is? Okay, so they started this problem right. You have 26 equals 10 minus b. I agree with subtracting 10 from both sides. But what happens here is that this minus can't just disappear. So this has to stay a negative b, and then you have to get rid of that negative. We could think of this as a negative 1 multiplying the b, meaning that to get rid of it, we need to divide both sides by negative 1. We get negative 16 equals b, or switched around, b equals negative 16, which is different than this. Okay, and with problem number 4, looks like they added 6 to both sides. What should they have done? Here, we'll pause the video. All right, so adding 6 doesn't undo what's being done to the variable. We want to isolate x. X is being divided by 19. So what we need to do is multiply both sides by 19. So times 19 times 19. We get negative 6 times 19 equals negative 114. Or switch that around, x equals negative 114. Put a box around that. Okay, so that's how we solve all of those correctly. All right, next up, our goal is to be able to solve two-step equations today. Why we're doing this? To continue practicing our inverse operations and the balancing method. And once we can solve two-step, then we can move on to three-step and four-step and as many steps as we want. But we have to know which order to do the steps in. That's what today is all about. So, according to PEMDAS, what would I do first? Here, I'll embed another question for you to tell me. Okay, so the correct answer is I would do the multiplication first. All right, so multiplication comes before addition in PEMDAS. All right, soon we're going to learn about SADMEP. SADMEP is PEMDAS backwards. And this is the order we undo operations. This is the order we undo. All right, so normally I would multiply these first, then add. If I wanted to undo that, I would subtract and then divide. Got to use inverse operations. So if we look at this expression here, in what order would we change the variable in the following expression? Let's write it out. The very first thing we would do to the variable, because of the parentheses, is we would add 2. The second thing we would do is we would multiply by 3. Because of this 3 on here. And then the very last thing that would happen is we would add in the 5. All right, when we solve, we have to go the opposite direction. So whatever is the last thing that would happen to the variable is the first thing we're going to undo. So go the opposite direction when we solve. Another question for you. How do we put up and take down a tent? So the very last thing you do when setting up the tent is the very first thing you undo when you take the tent back down. So I'm trying to hopefully build up this metaphor of whatever is the last thing we do is the first thing that we undo. All right, I think we're ready to solve a multi-step equation. What value of x makes this equation true? So you have to ask yourself, what order are things being done to the variable? It's being multiplied by 2, and then it's being added by 2. Then you got to say, how do I reverse those operations? So the last thing that happens is this add 2, so it's the first thing we'll undo. We'll undo that with a minus 2. And whenever we do to one side, we have to do the other side. So I put a minus 2 over here as well. And what I'm left with is 2x equals 8. The 10 and the negative 2 make an 8. Now the x is being just multiplied by 2. That's the only thing happening on this side. So I use its inverse operation of divide by 2. I do it to both sides to reveal that x equals 4. If you divided by 2 first and then subtracted 2, you get the wrong answer. We have to undo it in the right order. All right, here's another example. Go ahead and copy it down. So this time x is being divided by 5, and then we're adding 7. And on the other side, we have just a negative 3. So focusing just on the side with the variable, we have to undo what's being done in the reverse order. So the last thing that happens is that plus 7, so we're going to subtract 7 from both sides. Now we've got x over 5 equals negative 10. Now the only thing being done is to divide by 5, so we're going to multiply both sides by 5, and I get x equals negative 50. All right, a good way to think about this is that we want to simplify early on, and this enables us to combine like terms even though they're separated by an equal sign. So subtracting 7, I'm combining these constants to become a negative 10 on the side away from the variable. All right, and just like we were doing with our one-step equations, we should be double checking this by plugging it back in. So let's do a double check. So I'm going to replace the x with a negative 50. Say negative 50 divided by 5 plus 7 equals negative 3. Negative 50 divided by 5 becomes a negative 10 plus 7 equals negative 3. And then this side becomes a negative 3. This side's a negative 3. It passes our double check. Okay, I'm going to embed a whole bunch more of these for you to try. And have a good rest of your day.